All right, good morning. I'm planning to do LeetCode contest 295 from a couple of weeks ago. I'm doing this one virtually. So here we go. All right, open these guys up. You can zero index strings and target. You can take some letters from S and arrange them to form new strings, return a maximum number of copies of target. Okay, so we can use a map and then determine how many of those characters are required for target to be created. All right, let's do this in Python. Okay, game plan. Okay, game plan is to use a map to keep track of the cost rate t and see how many we have and return that as the count. Return that as the count. Sounds good. Okay, so count is 0, which will return in the end. And then let's just do t. Let's do this. Hold on. 6, 8, and dash. Number of minutes for implementation. Let's do this. Okay, so let's say A is the first map, and then B is maybe the second map. Right, that works, right? A is what we have, and then B is the target. Actually, we just use a counter, right? So A equals counter. I wonder if this works. I'll print this real quick. I think it does, right? Yeah, that's okay. And just reduce from A that which is in B. All right. While let's see, if okay, B. All p-value pairs. Right, so all characters and cost for CX character count in A dot items. If there's enough B's in that thing. This is what we have for characters. We have X that we have or Y that we need and B dot items. F X Hold on, I'm skipping ahead, trying to come up with a super nice, perfect solution. But let's just do this. Well, we can take something, right? Wow. So I don't want to express this. Yeah, let's just write a function, right? It's fine, right? I was on the right path. Okay, so we want to take a b from a, and if we can, then it's fine. Let's just do this. Or x count in a dot items. We want to create the target from that's right. So this is what we need. If x not in a or a sub x is less than what we need. Let's see. Let's do this. How about have equals a sub x if x in a else 0. If need is less than have, return or just break, right? Otherwise, we'll take it and increment the count. So a sub x minus equals need. Okay, I think that'll work. Let's see what happens. Uh-oh. Should be 2, but that doesn't look right. Okay. So infinitely for every value in B, it's our character and it's the quantity that we need. Oh, what we have is less than what we need. There we go. Okay. This backwards, but that should work, I thought. Hmm. Let's do this. Print A and print B. I wonder if that'll work. CODE, right? C O D E. That's right. C is 0 after that. So we can make 1. Here we made 1. Here we made 2. This is a need. C0. How is this not occurring? X and A as 0. Need one, we have 2 C's. We need 1, we have 4 O's, right? That looks fine. So you're going to construct 1 here. We can construct 2 there. Needs exceed what we have. We have less than what we need, right? We have less than what we need. So why doesn't it break? What the hell is this? Oh. Return the count here. All right. Okay, yeah, okay, that makes sense. Okay. Okay equals true. Okay. Okay, is false. As long as it's okay. All right. I think that works. 2, 1, and 1. Looks good. Okay, cool. 608, 619. So that's about 11 minutes. Right, so we have 2 counters and then just take what we need. Do we need whatever we need? Okay, cool. Let's do this in the other languages here real quick. View solutions. Iteratively take iteratively check. It is okay to take what we need from what we have. I guess return the quant. Let's take, that looks good, right? Kotlin. Oops, JavaScript. On 3. Rust. C++. Let's change this to take. All right, so take is this guy. Tick. All right. While it is okay to take yes, sir. Yeah. To store the frequency of each character the input strings T correspondingly. That looks good, right? Use maps A and B to store the frequency character, the input strings S and T correspondingly, and take what we need from what we have, right? That's cool. Okay, let's implement this and move on. It doesn't have to be perfect. It's good enough. So this will be our counter. Map. Character count. And B. Or each character S. Or just call it X. A sub X. Or each character T plus B sub X. And then while, okay, true, okay, take, okay, take each character count in target. Can we take that from pass? Have is A sub X. This is need. If have is less than need, okay, that's false. Otherwise, A sub X minus equals need. Okay. Uh-oh. Cannot decompose. Oops, and some B. That's not right. We're counting too many. Take. Oops. If take plus equals, okay, right. Okay, that's good. Cool. All right, grab this guy, stick it here, move on. Okay, let's do JavaScript. A is a new map. B is a new map. And take, so we can take, return take in the end. Or let's see, S. A dot set C 1 plus A dot get C or 0. Do the same thing for T. Or we can just call it X, right? Just be consistent, whatever, it doesn't matter. Okay, and then okay, goes true. Okay. Take this goes. Okay. Then or let character X and what we need of B have is A dot get X 0. If have is less than what we need, then okay is false. There's A dot set X. A dot get X minus need. Uh-oh. Take is 0. Oops. Okay, that's good. Yay. Okay. All right, let's do Kotlin. Global map, character to integer count. And global map, character to integer count. Or, oh, actually, let's do this. Var a s dot group by it dot each count. B will be T, and then okay equals true. And we can take 0. Okay, take this equals if okay 1 0 and 4 x need n b have is a sub x if what we have is what we need, okay, is false. Ace equals a sub x. I just need. Okay. Oh. Count. Receiver type mismatch. Doesn't know what T to char array. Does that work? A two char array that group by it at each count. Could have sworn I've already done something shorthand like this in Kotlin. Hold on, let me look at this. Oop. Open it up here real quick. Do each count. Each count. Oh. I thought I would have had an example here. Dang. Hmm. Let me look if I can find this real quick. String character count group by each count. Grouping by group by Huh. Could have sworn I already looked at this and made a solution. I'm pretty sure. When was the last one I commented on? I think it's VirtueBox. This one? Hold on. VirtueBox. I'm pretty sure. Yeah, I did this, right? It's dot grouping by. Aha. Okay, it's grouping by. Oops. Okay. Grouping by. Grouping by it each count. Oh. A sub x, no set method providing array access. Oh, each count. Dot. Look at this again real quick. I thought I had it. Hold on. Two list of two typed array, really? Two mutable map. I wonder if that works. And that's what I want. Basically, it's a mutable map, so I can take stuff that I need. Okay, cool. Yay. Okay, so Kotlin, JavaScript, Python 3, C++, and then Rust. Okay. Let mute take 0, we're taking the end. Let mute, okay, was true. Oops. True. Well, okay. Then let mute a equals I'm not sure how to do this functionally in Rust. I'll just do this for now. We'll do it the long way. B is hash map. Use C collections hash map. For X and S dot chars. A dot the object and location A dot entry of X dot or insert 0. This was 1. Do the same thing for T. For we need E have equals A dot get X dot or on wrap 0 if what we need is less than what we have. Okay, it's false. A dot entry X. Okay, something like that. Can start borrowing here. Yes. Borrow that thing. Expected. Bro. Consider dereferencing the borrow already. Yeah, I still don't really understand Rust that well. So, oh no. Need and have. I think we'll come back and fix this one up. I want to come back and have time for the other questions. Okay, so I got it took 35 minutes. Okay, so we have 56 minutes left in the contest. 6 minutes remaining in the contest. So Q1 took about 35 minutes total. And I totally struggled with the rest. That's definitely room for improvement. So there we go. All right, synthesis strings, single spaced words. Okay, yes, digits, lowercase letters, $sign. Word represents price of a sequence of digits preceded by a $sign. The $sign is a prefix. Fine. Okay. Sure, a string representing a modified sentence. That all prices will contain at most 10 digits. There are $1, $2, and $5 candies in the loop. Discount 50. That's a percentage. $10 digits. We have 10 digits, and what does that mean? It could be a 1 followed by 9 zeros, a billion. Sentence, and our discount will just be X. Doesn't really matter, right? 6:42 a.m. over minutes. Oops. Implementation. Implementation. Let's get going. So I need to determine if I want to modify it or not, right? So let's do this using the vector string. String s string word. Get a word from the string. So we want to determine if it's something we need to modify or not. Like we want to modify the word if the prefix starts with the $sign and the rest is an integer. Is, we want to call this thing price. Is price. This word if it is a price. So if word sub 0 is not equal to the $sign, immediately return true or return false. Individual index is less than word dot length. $100% discount. It was like 99% discount. Get some weird rounding errors. Word size is less than 2. Then most certainly all the rest are not going to be digits. If is digit. Or let's just do this. S is fine. S is our word string. Say I, return false, is return true. Okay, so is price. Just do this. Vector string. Copy. String iterator. String. A stream iterator. Back insert a. Let's see. I think this is right, but I'm going to just double check. Might as well print it right. Okay, so these should be our words. String There, right? Okay, cool. Answer is this guy. Turn the answer in the end, and then oops. Oh, white space, right? B. String, s. String. Iterator. And let's go to this. Str. Something like that. Okay, so copy it there from here, and then we need to modify it as it's a price. Okay, so for s and if not, it's price s. Continue. Otherwise, if it is a price, then we want to modify it based upon the discount, right? So the discount is a percentage, which can take us double, right? Ratio is a double x divided by 100. Subtract that much, right? Ratio that we subtract is take the ratio x divided by 100, right? Take the ratio is fine, right? Double x divided by 100. So 0.5, that would be 1. So we're gonna have have is string to integer s dot subster 1 onwards. Have times the ratio. Discount ratio times what we have. And it has to be equal to s equals string $1 append so we need to set the precision to 2. Hold on. Set the precision to 2. $. That may or may not work. I don't know. We'll see. We'll have to fix it up a bit. Oops, I still like size. Error 0.05. How do you set the precision on this thing to 2 then correctly? Double with precision 2. Not full precision, but set precision. Set precision. I thought that would do it. Okie dokie. Let's set precision 2. Nope. No number set. Yeah. Hold on. Max digits. See how that precision. Does that work? 2. Nope. Okay. How the heck? Fixed. Fixed. It's around. Hold on. C equals this round to hundredths. Yeah, that's what I want. Yeah, that's what I want. So that's right. So print is. That's what I want. All right, print double 2. Fixed. Fixed sex precision. Okay. Fixed. Looks right. Okay, hold on. Just compare this output here real quick. This is what I'm expecting, and this is what I got. Wait. Output. Run this guy. Okay, so that's the first one. This is the second one. Six. So that's not right. Discounts 100. Okay, so have minus equals discount. We have left. That is not right. Have. Turn this into double. Double this guy. Okay, that was good. Oh. Take the discount. So on. Okay, these are my answers. These are the expected answers. All right, so this guy should match this guy, and that guy should match that guy. Okay, that looks good. Oh, out of range. Oof. Okay, so 6:42 to 7, about 18 minutes for implementation, which results in the wrong answer. Oops. Okay, let's fix this up. Right, so this guy is too big, right? That makes sense. It's a billion, but this is 7 billion, which is too big for an integer. So yeah, let's just stick it into long, right? Stole. This one's cool. %. Okay, that looks all right. Yay. Okay. Wow. Yeah. Obviously, C++ is super for betters. Whatever. It's not necessarily algorithmically complicated, but it does take some time to express. And it's good practice for coding, I guess, right? It's all good practice. It's all good. 3. Oops. Python. 3. Plus. Okay. So that's that. All right. Let's do this in Python. That's our sentence. That's our discount. A equals word for word and instance split. Just a white space is price each word. So if $0 does not equal $sign, or length of s less than 2, which are false. Turn true in the end, as long as all the rest are okay for I in range 1 to length of s, and s of I dot is digit, turn false. S A, if not, is nice as you return join at the end to modify it. Okay, so it's not a price, we continue, otherwise it is a price, so we'll modify it. Yes. I'll go grab some more coffee. Okie dokie. Was okay, so for each string in the array, it's not a price, we continue, otherwise it is a price. So we will say what we have in the ratio. And so have equals S1 onwards is an integer. So float tab up. So we have ratio is what we have times discount right. Well, and ratio is that guy times 100 as a floating point value. Take equals half times right the ratio of what we have. Ratio is this. Ratio never changes, though, right? Whatever. I don't have to calculate over time, but having it there is whatever. It doesn't matter. Is that actually perfect, right? Okay, so take ratio we have and have minus equals take. Okay, so how do you let's see Python format float 2 decimal places? Yeah. colon.2f this equals colon.2f. What? Format, okay. Hold on. Tipping these real quick. Not sure how to do this offhand. Okay, dot format flow. Interesting. What we have. And just stick a $sign in front of it. That didn't work. before, S after. I look like this by reference, so it's strange. It's not modifying it. Whatever, we'll just make this functional. Discount. Okay, so then we'll just do this, right? So return word for, let's see, discount word if is price word else word tick join all these guys together. Okay, that looks good. Okay, cool. All right, yeah, for certain functional programming shines here compared to C++'s procedural programming, right? So we have a discount and a price, right? And that's all I have to do. Okay. JavaScript. Sentence, discount. That is price. As return true the end. If s of 0 is not equal to $sign or is total length is 2, sure it's false, otherwise I goes minus less than s to 1. If s of I is digit, the ASCII ordinal value would need to be less than, or let's do this. Let ord equal c dot char code at 0. Ordinal value, right? So let low high equal the ordinal value of 0. The ordinal value is 9 inclusive. If s of I is less than the ordinal value of the character, less than the ordinal value of low, or s of I exceeds high, turn false. Okay. Let's just split on words. Turn a dot showing to words. Right. If not, it's not a price. Continue. Otherwise, let's do this. Right. Let discount. Just do it functionally. Turn discount string. nav equals number s dot slice of 1. Ratio equals x divided by 100. Nav is this guy. Take ratio times have. This is what we take. Turn, take more sign. JavaScript. Format. 2 decimal places. 2 fixed 0, 2 fixed 2. Have that 2 fixed 2. Discount. Turn. S dot split dot map each word. If, let's see, is price word, discount word, was just the word plain up, and join back into a sentence, white space delimited. Looks good. Yay. Okay. Thank goodness for functional programming, JavaScript, and Python 3 most definitely make my life easier compared to C++. My God, look at this thing. Okay, Kotlin next, and let's move on. I'm spending a lot more time on this than I was hoping to. Oh, well, that's usual, I guess. This price. Boolean. If s sub 0 is not equal to $sign, or s dot length is 2, return false immediately. Return true at the end here, as long as for line 1 until s dot length. If s sub I, let's see, line character is digit, char is digit, it's not a digit, return false. Discount string, this will return string. Turn sky. Have in the end here. Format the 2 decimal places. Ratio is x divided by 100.0. R we have is s dot substring. Let's turn out 1 at 2 double. Our take is ratio times have. Have minus equals take. Let's see. Kotlin format float 2 decimal places. Decimal format, interesting. Decimal format. Dot format. That's cool. Okay. Return decimal format. Oops, hold on. Decimal format this thing. Oop. $sign dot $sign. Format. We have string relation to this guy here. Okay, and then return s dot split. Map. If is price, it's discount it as it dot join to string, something like that. Compile error, have minus equals take substring. So not correct. The formatting is not correct. Format. String dot format. Percentage dot 2f. String dot format. Dot percentage 2f. We have string dot format. Oh, hold on. I wonder if this works. I don't think so. We can do this though. Formatted is this guy. Oof. Too many zeros. The heck? Set scale. Pick decimal. And that's what I want. Good decimal, that's set scale, running mode at floor. Or that's set scale 2. So 2, rounding mode at floor. Rounding mode at floor. Big decimal. Big decimal of what we have. Okay, that looks good. Oh no. Floor. It's not the floor then. It's a different rounding mode. Rounding mode. Kotlin rounding mode. Rounding mode. Expect it to half up, right? Half up. Okay, expect 36, not 35. Looks good. Yay. Okay, oops. Grab this guy and I'm just going to skip Rust for now. Do this later. To do, implement me. Good enough for now. Come back and do Rust. I have time. I'd like to get to Q3. Oh, like the whole contest is gone. Okay. Well, we got two. Price. So if it is a price, we discount it. I feel like cleaning up C++ here. Why is he so many downvotes? People suck at coding. Give it an upvote. It's cool. Okay, let's do this functionally. So auto discount s. That guy. Okay, and then transform the array. Is a price. Then discount price, otherwise S as is. Okay. X cannot be explicitly captured in lambda. Take it by value. Discount should be passed in by reference. Okay, so that's cool. C++ is verbose version of being a functional programming language. It's really sad to see so many complaints. What a bummer. Yeah, it's not algorithmically complex, but there's still something to be learned about just basically coding, right? I mean, that's all there is to it. All right, whatever. Don't give that negativity any energy. We got 8 minutes left. Let's see what happens on Q3 here. Let's start with JavaScript this time first. How about 7:28 a.m. Okay, so here's my game plan. Zero array. Remove all elements ASAP. None. However, this one's bigger than that one. Return number of search forms non-division, right? Okay, so we should be able to use a monotonic queue, right? Monotonic queue is what I'm thinking offhand. Monotonically non-decreasing. Kick those out. 5, 7. Yeah, okay. Okay, game plan is to use a monotonic queue implemented as a stack, which we kick out violations. Let's do this. Okay, so this game plan, 7:29, 1 minute game plan, and then let's do the implementation. That'd be cool if I can get this done in time. Yeah, 7 minutes. So here we go. That's for implementation. Implementation. Okay. There's our array of numbers, which will return in the end, right? This is our stack. Just call it a stack, whatever. Oh, we don't know. It's right. Okay, so stack will be what we push. Return in the end. So A. Okay. While the stack is not empty, and s of s.length +1 violates the non-decreasing, right? So if this one is bigger than that one, s.pop, s.push. Okay. Uh-oh. Total steps. Oh, okay. 0. Step 1. Oh, you go through one at a time. Well, there's violations, right? That get kicked out. The violations get kicked out. Oops, not S, but I want to return count. 7. No, it is not 7. Okay. Not quite right. How many violations are there initially? So this one we might need to remember the past to find the future or do something. So here's the deal, right? So, okay, so it's incorrect implementation, 7:32. Let's see, about 3 minutes for implementation, which is incorrect. It is too naive to simply use a monotonic queue and count violations. Popped off stack. How many rounds did we are looking at the count of rounds? the immediate ones, adjacent. Okay, yeah. Something tells me I'm not gonna get this done in 3 minutes. So definitely come back to this one in upsolve. It is interesting. Down, up, down, up, down, up. I can't go through it this many times though, because it'll TLE for sure. But it seems like, okay, so come up with a better plan, right? Okay. So here's the deal, right? So here's the deal. N equals 185. So we need near runtime solution for AC, a naive simulation is quadratic and thus will result, will result in TLE. However, brute force is a good start. Right? Make a correct solution, then optimize it. So while A is not sorted in a monotonically increasing order, we'll reduce it one round at a time. That one's bigger than this one. That's false. True. Well, it's not okay. We'll reduce it. Increment the count. Indices for deletion. Nine seconds left. Okay. Well, I'll do brute force and I'll try to optimize it next to upsolve it. Catch you next time.